So let us consider the example for the Shannon Fano coding. So let us start with an example for Shannon Fano coding. Consider a discrete memoryless source with symbols x1, x2, x3, x4, x5 and x6 with probabilities 0.4, 0.1, 0.2, 0.1, 0.1 and 0.1. Construct Shannon Fano coding. So this is the question. Okay, so we are given with some 6 type of sources, and with these 6 type of sources we have to construct Shannon Fano coding, and we have to find out the efficiency. So whatever the problem has been given and whatever they have to find out, we have to find out. First, write what are given. So given is nothing but 6 things, that is x1, x2, x3, x4, x5 and x6. Okay, and write down probabilities, that is 0.4, 0.1, 0.2, 0.1, 0.1 and 0.1. So first we have to write all the given symbols and their probabilities. So what we need to find? We need to find efficiency. Okay, so efficiency eta. Before that we need to apply Shannon Fano code, or we need to construct Shannon Fano code. Okay, so we can see how we are going to do this. Okay, so whatever the problem may be, so we have to find first, we have to write down the given data. What is the given data? Some symbols they have given, 6 symbols they have given, that is x1, x2, x3, x4, x5 and x6, and their probabilities 0.4, 0.1, 0.2, 0.1, 0.1 and 0.1. So we need to construct Shannon Fano coding for this data, and we need to find out. First step in the Shannon Fano coding is step 1. Step 1 is arrange the probabilities in decreasing order. Arrange the probabilities in decreasing order. Okay, so this is the first step. Arrange the probabilities in decreasing order. So I am writing the probabilities in decreasing order and the symbols. So first probability 0.4, and next one will be 0.2 in decreasing order, and then we will be having 0.1, 0.1, 0.1 and 0.1. Okay, and the symbols will be x1, x2, x3, x4, x5 and x6. We can change the probability of symbols, no problem. We have to write in decreasing order the probabilities, that is 0.4, 0.2, 0.1, 0.1, 0.1 and 0.1 in decreasing order. Okay, the first step in the Shannon Fano coding is arrange the probabilities in decreasing order. So this will be your first step. So proceeding into the next step, we need to draw a tabular column. So we can draw the tabular column. Consider probabilities. And consider 3 stages. Stage 1, stage 2, stage 3, code word, and link. Okay. So for proceeding to the next step, you require this tabular column. Step 2 will be this tabular column. Okay. Okay. For going to step 2, we need to draw this tabular column. So this tabular column consists of probabilities, stage 1, stage 2, stage 3, code word and length. Okay, I repeat again. For proceeding into step 2, we require a tabular column. That tabular column consists of probabilities, stage 1, stage 2, stage 3, code word and length. So I have written the probabilities in decreasing order. 0.4, 0.2, 0.1, 0.1, 0.1 and 0.1. Okay, so I have written down the probabilities in decreasing order. So what is step 2? Divide the set of probabilities into equiprobable messages. Okay, into equiprobable levels. So we have to divide the set of probabilities into equiprobable levels. For example, you see 0.4, 0.2, 0.1, 0.1, 0.1 and 0.1. When you add 0.4 and 0.2, you will be getting 0.6. And when you add all these three things, 0.1, 0.1, 0.1 and 0.1, you will be having 0.4. So divide equiprobably. Okay, step 2 will be divide equiprobable. So when you add both these two digits together, you will be getting 0.6. And when you add all these together, you will be having 0.4. So 0.4 and 0.6 have some minimum variation. So we are dividing equiprobable. Then we have to assign the numbers for those equiprobable messages. So I am assigning 0, 0 to the upper values and 1, 1, 1, 1 to the lower values. Okay? So I have written down the all probabilities in the in the decreasing manner, and then I have divided the probabilities into equiprobable manner. Okay? So first one will be the 0.6 value, and when we have all the 4 points, that is 0.1, 0.1, 0.1 and 0.1, you will be getting some 0.4. So for I am separating 0.6 to one level and 0.4 to one level. So I am assigning the values to a particular point. So 0, 0 will be assigned to the 0.4 and 0.2, that is the upper level, and 1 will be assigned to the lower level values. Okay? So next stage, again you have to do the same procedure until the division is not possible. Okay? So we have to repeat the same procedure until the division is not possible. So consider this particular first point here. So 0.4 and 0.2 here. Okay? So we can again separate this 0.4 and 0.2. So when you separate this 0.4 and 0.2, you will be having the value as 0, 1. Okay, you can separate this 0.4 and 0.2. So the upper one can be further separated. So come to the lower one. In lower one you are having 2.1 and 2.1. So again you can separate here. So in the lower one also you can separate. So you will be having what? You will be having 0, 0, 1, 1. Okay, so in the upper one, in the second stage, you are again separating the two values, and in the lower one, in the stage 2, again you are separating these 4 values into 2 each. Okay, and now go for the stage 3. So in stage 3, we can check with the 0.4 value, there is no separation required because only one value is there. And coming to the 0.2, no separation required, only one value is there. But when coming to this particular point here, we will be having 2 values, 0.1 and 0.1. So you can separate 0.1 and 0.1. And again, when you come here, you are having some 2 values. Again, you can separate 0.1 and 0.1. So in stage 3, you will not have any values for this 0.4 and 0.2. But for this, you will be having 0, 1, and again you will be having 0, 1. Okay, you cannot separate this 0.4 and 0.2. Okay, but you can separate this 0.1 and 0.1 and this 0.1 and 0.1. So this will be the upper bound and this will be the lower bound, and again this will be the upper bound and this will be the lower bound. For the upper bound you have to add 0, and for the lower bound you have to add 1. Again for the upper bound you have to add 0, and for the lower bound you have to add 1. Okay, now write down the code words. So what are the code words? So for 0.4 we are having the code words 0, 0. And for the 0.2, you are having the code words 0, 1. And for the 0.1, you are having the code words 1, 0, 0. And for the 0.1, you are having the code words 1, 0, 1. And this for this 0.1, you are having the code word 1, 1, 0. Okay? And for this 0.1, you are having the code words 1, 1. So this is how we have to write the code word for each probability. So first we have to write down in the decreasing order of probabilities. After writing down in decreasing order, need to segregate each probabilities according to the probable message level, and this step must be continued further when no segregation is possible. Okay, so we can able to find out the code values and we can write out the code word level. Okay, so first what we have to do, first in this we have to write down in the decreasing order these probabilities, then check 0.4 and 0.2 when we add together you will be getting the 0.6 and you will be having 0.1, 0.1, 0.1 and 0.1 added together you will be having the 0.4. So first we have to separate these two values, okay, separating these two values. So 0.4 and 0.2 will be in the upper bound and all the other 4 points will be in the lower bound. So for the upper bound in stage 1 you are writing 0, 0 and for the lower bound you are representing as 1, 1, 1, 1. Stage 1 is over and you are coming to the stage 2. In stage 2 you can further divide upper bound into two parts and lower bound into further two parts. So in stage 2 in upper bound you are having two values 0.4 and 0.2 which can be separated further. So I am separating here. So I will be having 0.4 and 0.2 are separated. So 0.4 will be the upper bound and 0.2 will be the lower bound. So 0.4 will be having the value of 0 and 0.2 will be having the value of 1. Okay, this separation is over. Again, when you come to this particular lower bound, you will be having some 0.1, 0.1, 0.1 and 0.1. So this particular stage 2, this lower bound can be separated further into 2. So I am separating here like this. So I will be having 0.1 and 0.1 in the upper bound and 0.1 and 0.1 will be in the lower bound. So for upper bound I am getting the value of 0, 0 and for the lower bound I am getting the value as 1, 1. So stage 2 is over. Now I am coming to stage 3. When I come to stage 3 I am noticing that there is no further transition is possible or further separation is possible in this 0.4 or 0.2. But when I am seeing this particular 0.1, 0.1 and this particular 0.1, 0.1, furthermore transition can be possible. So again I am separating this particular 0.1 and 0.1 as another stage and again I am separating this particular 0.1 and 0.1 as the another stage. So again now I am representing as 0, 1 and again I am representing as 0, 1. Okay, so again I am representing as 0, 1 and again I am representing as 0, 1. This upper bound will be 0 and lower bound will be 1 and this upper bound will be 0 and lower bound will be 1. So what next step what I am doing, I am writing down the code word. So I have to add together all the code words written in all these stages. So for 0.4 I am having the code word 0, 0 and for the 0.1 I am having the code word 0, 1 and for 0.1 I am having the code word 1, 0, 0 and for the 0.1 I am having the code word 1, 0, 1 and for 0.1 again I am having the code word 1, 1, 0 and at last for 0.1 I am having the code word 1, 1, 1. Okay, so in this manner you will be writing down all the code words for the probabilities. Next will be the length. Length is nothing but length of the code word. Okay, so length of the code word. How many bits are there? 2 bits. So first code word 2, second code word 2, third code word 3, fourth code word 3, fifth code word 3, and sixth code word 3. So length is nothing but the length of code word. This is very, very important because based on the length only you can able to calculate the L bar value, and based on the L bar value and code and entropy you can able to calculate the efficiency. Okay, so length is nothing but the total number of bits available here. So for 0.4 you are having 2 bits, so 2. 0.2 you are having 2 bits, 2. For 0.2 you are having 3 bits, 3. And again for the 0.1 you are having 3 bits, 3. And for the 0.1 you are having 3 bits, 3. And for last 0.1 you will be having 3 bits, 3. So this is the length of code. Hope Shannon Fano coding is calculating efficiency. The next step in the Shannon Fano coding is calculating length of the code. Okay, so it will be denoted as L bar. Okay, the formula for L bar will be summation k is equal to 1 to k pk into nk. Okay, L bar is equal to summation k is equal to 1 to k pk into nk. That this L bar will be the average length. Okay, so average length of the code. So when we expand this L bar, we will be having P1 N1 plus P2 N2 plus P3 N3 plus P4 N4 plus P5 N5 plus P6 into N6. So these probabilities P1, P2, P3, P4, P5, P6 are already written in the decreasing order. That is 0.4, 0.2, 0.1, 0.1, 0.1 and 0.1. And this N1, N2, N3, N4 are nothing but the length of the code. Okay, so we all know that N1 value is 2, N1, N2 value is 2, N3 value is 3, and N4 is 3, N5 is 3, N6 is 3. You can refer the tabular column which is drawn in the previous page. Okay, so this P1, P2, P3 are nothing but the probabilities which are written in the decreasing order, whereas this N1, N2, N3, N4, N5, N6 are the code length of those probabilities. Okay, so probabilities and N1, N2, N3, N4 represents the code length of those probabilities. So when you write all these together, you will be having 0.4 into 2 plus 0.2 into 2 plus 0.1 into 3 plus 0.1 into 3 plus 0.1 into 3 plus 0.1 into 3. And when you find out the L bar, you will be getting 0.8 plus 0.4 plus 0.3 plus 0.3 plus 0.3 plus 0.3. So when you add all together, you will be having 0.8 plus 0.4 will be 1.2 and 1.5, 1.8. Okay, sorry, 1.2, 1.8, and all together you will be having some 2.56. Okay, so 2.56. Okay, this will be the answer. Okay, 2.56 bits per symbol. The unit will be bits per symbol. When you add all together, you will be having the value as 2.56 bits per symbol. Okay, so this is the average length value. That is the L bar value. So one small change, it is nothing but 2.4. Please change it as 2.4 bits per symbol. I made a mistake, sorry. 2.4 bits per symbol. So this is the L bar value. Next, we need to calculate the entropy. Okay, L bar we have calculated, and we need to calculate the entropy. So, entropy. You all know the formula for entropy. Last class we have tried some problems in the entropy. So, entropy H of S. Okay, H of S is equal to summation K is equal to 1 to 6 because we are having only 6 probabilities. P suffix K log base to 1 by Pk. So, this will be your formula. Okay, for entropy the formula will be P suffix K log base to 1 by Pk. So entropy can be calculated as H of S is equal to same formula P1 log base to 1 by P1 plus P2 log base to 1 by P2 plus P3 log base to 1 by P3 plus P4 log base to 1 by P4 plus P5 log base to 1 by P5 plus P6 log base to 1 by P6. So we have expanded the entropy formula. Okay, so substitute the corresponding value. H of S is equal to, so what will be the P1? 0.4 log base to 1 by P1. Okay, 0.4 log base to 1 by P1 plus 0.2 log base to 1 by 0.2 plus 0.1 log base to 1 by 0.1 plus 0.1 log base to 1 by 0.1 plus 0.1 log base to 1 by 0.1 plus 0.1 log base to 1 by 0.1. So when you solve this for entropy, you will be having the value of H of S is equal to 2.322 bits per symbol. So when you calculate it, you will be getting this value. Entropy will be 2.322 bits per symbol. Okay. So the H of S value will be 2.322 bits per symbol. So we have calculated the L bar value and we have calculated the H of S value. And next we need to calculate the efficiency value. Okay, the next will be the efficiency value. And the code efficiency formula will be code efficiency formula will be eta is equal to H of S divided by L bar. Eta is equal to H of S divided by L bar, and we know H of S value as 2.322 and L bar will be 2.4. Okay, H of S value will be 2.32 and L bar will be 2.4, and when we divide it, we will be having eta is equal to 0.967. We will be getting value as 0.967, and percentage efficiency will be equal to 96.7%, and percentage efficiency will be 96.7. And next will be redundancy. Even though it is not asking problem, we can just check it. Redundancy. So redundancy is nothing but small r. Small r is equal to 1 minus eta, which is nothing but 1 minus 0.967, and the answer will be redundancy r is equal to 0.033. So for calculating the efficiency, you need to use the formula H of S divided by L bar, and for calculating the redundancy, you use the formula 1 minus eta. So for calculating efficiency or redundancy, you must know the value for H of S, that is entropy, and you must know the value for L bar. For L bar and entropy, we have to draw the tabular column, which we have discussed in this step 2. Okay, so this is the general method for constructing Shannon Fano code, and this is a very important question when you consider your first unit. So in the next class, we can discuss about the Huffman code. Thank you.